Okay, so good afternoon, everyone. So today, me and my teammates are presenting the project about crash severity analysis through machine learning model, and which is in the data analysis in construction management subject. Uh, me and all our team members, we are group 10, and you can read the name. Our project is guided by Dr. Lu Gao. First of all, we comes on the introduction part. So what is the road accident? Road accident are the most important general health concern. Like today, numerous injuries and deaths worldwide basis on the road accident. The report says 1.25 million people are affected during road accident, like they are killed, and which is ninth greatest cause of mortality globally. So road accident have so many types of causes, like speed of the car, the weather of the car, the car condition, the health of the drivers. So there are so many things which is a concern about the road accident. So we choose the data set about Missouri State Highway Patrol data. First of all, we analyze two or three data like Pennsylvania State data and Kaggle, but that those are data is not uh, proper, or I can say it is not completely verified. So we choose Missouri State Highway Patrol data. There are more attributes, so we can analyze more data and more causes for the accident. So our goal is to identify the causes or of the accident in order to stop the similar kind of accident in the nearest future. So first of all comes to the data pre-processing part. We remove the duplicates based on a certain criteria, and rename certain columns, so we can play with the more in that column. So and we total three Excel data, large data, and we merged all of them, like crash people, crash vehicle, and crash summary in one file, and some converted all converted into numerical values, and we gave 80% as a training data set, and remaining 20 as a testing purpose. So let's go our next part, plotted graph, which is explained by my teammates.
Yeah. So with respect to plotted graphs, we have just done the analysis using the Missouri data, which we have already seen in our midterm presentation as well. So we'll be just going over a few of the graphs. So the first graph is accidents over injury type. So we can see there are five major types of injury, which is minor, moderate, serious, and fatal, and the other conditions where people have not got injured. So with respect to this, we can see almost 50% of the injury is in minor, and other 50% is divided between all other four groups. Next, so we will be seeing accidents over gender. So we can see here who contributed more towards the accidents, male or female, but there is no much difference. It's hardly 8% difference, and male is contributing almost 54% in this. So in the next graph, we can see accidents over age. So we have divided the age group into total five groups, where below 18, 18 to 25, 25 to 40, 40 to 60, and greater than 60. And as we can see, almost 26% of the accidents contribution was from 40 to 60 age group, and the least was contributed in the age group where they're above 60 age. So might be the reason that they have stopped driving, they travel less, and that might be the reason as well. So the next one. So here we can see the distribution of safety device, injury types, and accidents. So we can see the blue is S, that is the safety device is present, and no is the safety device is not present. So whenever the safety device is not present, the injury seriousness level increases from none to fatal. But whenever the safety device is present, we can see the injury level is decreasing. The fatal is less when when the safety device is present, and it is more when the safety device is not present, as we can see from serious fatal as well. To the next graph. Yeah. So this graph represents the complete 24 hours time slots of the day. So in this time slots, we can see that major number of highest number of accidents was present during 5 p.m. to 6 p.m. That is around 8%. And there is a less number of accidents between 12 a.m. to 6 a.m. because of the sleeping time. So this is what we get from this graph. And the next one, this is the number of accidents per days of week. So we have taken all the days of the week. And from this graph, almost Monday, Tuesday, Wednesday, and Thursday contribute almost similar percentage towards the accident, but the Friday and Saturdays contribute a little bit higher, and that might be the reason because of the weekends and people are traveling more on weekends. As per the next graph goes, yeah, this is we here we have calculated top 10 counties that is actually contributing towards the accidents, and in that top 10 we can see Jefferson is contributing majorly, almost 17%, and Franklin and St. Louis and Charles are almost in the similar range of 12%. Yeah, so this is what the top 10 counties look like. So this is the last graph where we'll be showing the most keywords that were appeared in our report. So we can see from this uh, uh, word things that tree and ditch has been like appeared most number of times, almost 20% and 23% of time. So we can see most of the accidents in the data which we analyze, we can say were due to hitting a tree or something was with respect to trees. That's the reason the most calculation was for tree. And there are other things as well: animal, pole, snow. Maybe somebody went, animal ran towards the highway, or somebody hit the pole and due to snow. And these are the few things. So we have collected all the main words here. So this is up with the um, plots. Now Srinidhi will continue with the models.
Hi. So for this project, we're using 6 different models. The first one is logistic regression. I- all the 6 models are classification models. So these 6 are one of the most widely used models. So in logistic regression, it's basically we're using log odds. And the second one is k nearest neighbors algorithm, where we create clusters by calculating the distance between the neighbors. And then the third one is support vector machines. Basically, we segregate the data into groups using hyperplane. And then the other 3 are decision tree, random forest, and naive Bayes, which are also used for multi-class classification. And we split the data into training data and test data. And the test data will be using to evaluate the model. Coming to the model assessment criteria, the first point here is the true positive. This is when the model correctly predicts the positive outcome, and then we have the false positive is where it falsely predicts the positive outcome, and the true negative is when it predicts the negative for actual negative class, and subsequently the same goes for false negative. And we have 4 criterias where the first one is the precision score. The formula for this is true positive for by false positive plus true positive. This is used to calculate the accuracy. And then we have the recall score. This is again true positive by sum of false positive and true positive. And then we have accuracy score. This is the most widely used assessment criteria, where we calculate the percentage. And then we have the F1 score. And moving on to the demo, which will be conducted by Nirav.
Hello everyone. So yeah, so the first thing that we did is, as Vimal explained, we have plotted all these graphs using Python and inbuilt libraries of Matplotlib. So all these graphs are there. So we have plotted here. And as we can see, there are 3 parts basically. So we are divided into 3 different subgroups, and we worked on the different graphs. And there is a data pre-processing that Darshan explained. We have removed some duplicates from all the data files, and then we merged the data files horizontally. And after renaming the names, we make the data consistent. And we did some, like, we remove several keywords like unknowns and accept and safety device, as they are not needed. And yeah, from the date and time, we calculated the hour of the day and month of the year, as well as the day of the week. So this can be seen here. And then finally we downloaded the final version of data, which we used for the model prediction. So yeah, here I have loaded the final data version. And yeah, we can see that this is the first 5 rows of the data set, of the final data set. And yeah, we converted all the values into 0 or 1, sorry, numeric values, so that it can be made, we can work with data effectively. Yeah, then after we have splitted the data set into 20% as a test and 80% as a training. And then this is our first model, logistic regression. Yeah, so using logistic regression, we got all these values like precision score, recall score, accuracy score, F1 score. And we have noted all this into our presentation as well as our report. And yeah, so this is a KNN algorithm criteria. This is a SVM, support vector machine. And for the support vector machine, these are the values. That precision and recall score are 0. And it shows almost same accuracy as logistic regression, which is 83.3%. Then decision tree. So yeah, for decision tree as well, like, it is showing much good accuracy. That is, let's see, yeah, 73%, but not that much as of logistic regression. Yeah, the final, second last is random forest. And for that one, we got almost 81% accuracy. And for the naive bias, we are getting 82.31%. And yeah, for which coefficients are affecting more, that we plotted using a linear regression model, we got all the coefficients almost nearly similar. So yeah, there are three that we need to take look at is safety device, gender, and the third one is yeah, the damage. So yeah, and now let's go over to the PPT. So yeah, we have recorded all these values. So it can be clearly visible that logistic regression shows us the highest accuracy as well as precision recall and F1 score. Our conclusion is that logistic regression is the best choice for a classification model in our case. And there are three important features that we need to take a look at is safety device. So it is affecting me negatively. So if the safety device is present, then severity of the accident is lower, and if it is not, then severity is higher. Same is vehicle damage, it is positive. So if the vehicle damage is higher, then there are more chances that the accident was severe, and vice versa is also true. And gender, so gender is also affecting positively. So we have 0 for male and 1 for female. So if the sorry, 0 for female and 1 for male. So if from male to female, females are facing less severe accidents than of male. And thank you so much.